All right, so we're going to talk about recursive methods. Now, whenever you have a process that you need to repeat over and over and over, we basically have a couple options. So we can do iteration, which is like loops, like for loops, while loops. Okay, so we can do some sort of iterative method. But another option that we have is a recursive method. Now, a recursive method is unique from other methods that we've dealt with so far in that it calls itself. And that's how the repetition happens. So, without digging too deep in here, the main thing I want you to see first about this method, multiply, is that inside the body of the method, it calls multiply. It calls itself. So, when you run it, it will sometimes run itself, and then run itself again, and then run itself again. And that's how that repetition happens instead of having some sort of loop. Now, before we get into some of the uses and some of the advantages of recursive methods, let's talk a little bit about how they work. So, recursive methods basically need two components in order to work. So the first thing that you need is you need some sort of condition under which you're not going to recurse anymore. So in this case, if this condition is met, then we return 0, we don't recurse. All right? The second condition you need is a way of stating your problem in a recursive way. Basically, phrasing your solution in terms of another method call, okay? And that recursive definition that you have has to bring you closer to the termination condition. It doesn't matter if you keep recursing if you're getting further away from the finish line. If the finish line's over here and you're moving away, you're going to have infinite recursion. So let's look at this method real quick. This is a goofy example. We're just going to wind up multiplying these two integers here. So this would never be the way that you would actually implement this, but it's just a kind of simple method to start with. So let's say that we are doing multiply 3, 4. Okay. Now, let me use a darker marker here. Multiply 3, 4. Now, whenever you think about multiplication, at least like kind of in the elementary school sense, you might think about 3 times 4 as being 4 plus 4 plus 4. Okay, so 4 times 0 would be 0. 4 times 1 would be 1. 4 times 2 would be, would be 4. Then 8, and then 12. Well, what's happening to our numbers each time? Well, they're increasing by 4. So it's just 4 more than the previous. So that is what this statement right here is saying. It's saying that we're going to add 4 to whatever our previous value would be. So let's run through this real quick and see how this works, what actually winds up happening here. So let's call multiply 3, 4. Okay, so our x equals 3, our y equals 4. So the first thing we do is we check our termination condition. Is x equal to 0? No, it's not. So we're going to go down here, and we're going to call y plus multiply x minus 1y. So what does that wind up being? Well, that winds up being, okay, we're going to return 4 plus multiply 2, 4. Okay, problem is we don't know what this is yet, so we need to go ahead and call it. Recursive methods, when a method call occurs, you stop everything and you go ahead and run the method again. Even if you're not done running this method, which occurs in a lot of recursive methods, you stop whatever you're doing, you call the method. So let's go ahead and call 2, 4. All right. Well, so now we're calling multiply 2, 4. Is x equal to 0? No. So we keep going. So we do the same thing here. We're going to return 4 plus multiply 1, 4. Okay, and then what are we going to do next? It's going to be the same thing because we haven't gotten to x equals 0 yet. All right, and the good news is when we get here, multiply 0, 4 has a value. Because when we call this, x is 0, so it's going to go ahead and return 0. All right, so multiply 0, 4. I am going to mark this out and go ahead and say this is 0. Okay, well, what's 4 plus 0? Well, that is 4. Now, 4 plus 4 is 8. And then finally, we get to our last call. 4 plus 8 is 12. And that winds up being what we return here. Now, you'll notice that all of these individual calls are correct, okay? 0 times 4 is 0. 1 times 4 is 1. 2 times 4 is 8. So all of these individually are valid method calls. But we keep working backwards until we reach our base case. Okay, we reach our 0. And then it fills in those missing values in the recursion. All right, so this is an example of a recursive method. To review, a recursive method calls itself, and it needs 2 things to be successful, kind of 3 things. It needs at least one termination condition. A lot of times you'll actually have different ones. Then you need a way to state your problem recursively based on previous calls. And as you recurse, you need to move towards your termination, at least one of your termination conditions. Otherwise, you'll have that infinite recursion. So I'm going to show you a couple more examples in some more videos, but that's the basic idea.